嗯。老师什么这就很上高。人家微信版外卖，不要去了。还是要面对现实的。就是我们带一个闪电。一个路人。点你名字那个。我操。OK， 我靠。好。饭店，那你我觉得还是惨了，也不一样。我求你了，你，我讲一点，他都是我家。没有没有，上那个叫满分奖励，分奖励也是有奖励啊，要我的。哎，你说还是在地方知道的啊？我是做这个电脑的课。很有道理，对。因为其实是电脑屏幕的。对啊，我是要做个明显啊，我啊，在里面知道吗？连个是哪出来的？对，那你就自己对。我们想就是呢，肯定是不能因为呢，很早有的时候肯定就容易犯错，犯错对。其实就在中，不好意思，我是错，是吧？好啊，广告。哦，很多。我这等下我们会讨论答案，现在你看一下有什么漏改吗？分数少的，等下可以讨分。And then，你们拍照拍起来，在为这个要还有不要改里面的东西啊，有一个翻改的里面的东西给我抓到，不要在里面填东西。后面还会有没有？不会，你就拍起来做记录这样。以后可以我就跟起来了。比这个，因为学校要比这个。等下我们 check 完你就还给我这个 physical， 我们可以把它拍下来。电脑给我啊？不是电脑发给我吗？你拍啊？ 你不能拍，拍起来哦。啊，拍清楚一点就可以。
是说7+4
嗯
，7+4是
加太多了，
老师为什么我这个加错了？
加错了，加错可以跟我等下跟我讲，不要加太多。等一下，
这个
等一下。呀呀，
讲好了。
这样最高
不打是不打啊？
要不打的，怎么说呢？该这么说吧。
我改这么快？
对。你可以把它拍下来，等下这一份要还给我，我们会讨论一下，看一下有没有算漏算错了，就怎么样。
然后平均分大概多少？
等一下我们会说，我们会说。不用改先，等下记下来，等下告诉我。等下一次性告诉我。不要在那个paper 上面加东西 ，OK？记一下有什么算错啊、加分的地方，等下。有，我们等一下会讨论。Okay, then let's start. We'll discuss about midterm first before we go into the lecture material. Okay, so I want to discuss the exam based on this concept here. Okay, don't learn by learn by understanding, don't just learn by rote. Okay, so this exam paper I think is not less hard than previous year one. Okay, because I think I don't give you much time to check the question. What you can do is only just do, just based on your understanding, what you know, you write down whatever you know. Then I think it's almost the time for you. Okay? Yeah. So you don't have much time to check here and there for this paper. Is this what you feel during the exam? Sort of. Okay. Yeah, Hungry, this is your paper. Okay, please don't write on the paper yet. Don't write on the paper, okay? So I want you to recognize the difference. Okay, you come here, your degree is pure maths and applied maths, right? Your bachelor degree. Okay. So I want you to distinguish between arithmetic and mathematics. Okay. So what you're gonna do in this university is no longer arithmetic, it's mathematics. Okay. 不是算术啊，是数学。OK，我不要一直算。OK，我要知道知道自己在算什么。You have to know what you are calculating. Okay, what you are doing. Okay, it's not arithmetic but mathematics. Okay, we want to ask why we want to calculate like this. Okay, is there any way to calculate the same answer? Okay, is there a faster way, easiest way? Right. Okay, so first, this is the question for the first question. So for true and false question. So first question is, if I know that a sequence is strictly greater than the other sequence for every terms, does it follow that the limit of Bn greater than limit of An? Okay. Any confusion of understanding this statement here? Okay. So this statement is false. Okay, it's false. So you can simply pick 1 over n greater than 0. But 0 cannot be strictly greater than 0. Okay. And then every convergence sequence must be bounded. So this is similar to the practice exam question. Okay, so this is also false. Okay, you can use contrapositive. If it is unbounded, then by definition it is divergent. 3. 3 is a little bit tricky. When I let the head of department check the paper, he also thinks that this is true. So if I have a Bn bounded by squished by 2 sequence here, okay, and then I know that An and Cn converge. Okay, and then the limit is the limit of Cn is strictly greater than An. Then I'll say that the limit of Bn is in between these two limits. A lot of you solve by using squeeze theorem. But what's the difference between squeeze theorem and the segment here? Squeeze theorem says that the limit of the two bounding sequence have to be equal. Okay, but this one not equal. Okay, so there's some room for you to play around. Okay, I think 2 of you get my idea here. You can produce a counter example where Bn don't actually need to converge. Okay, because this 2 limit has a gap, so you can play room between this 2 sequence. Okay. And then fourth one is if a series diverges, then the series multiplied by a non-zero constant also diverge. This is the contrapositive for the property of convergent series. This is true. So only the fourth one is true. Okay, so my answer is here. You can have a read. Yeah, my answer is here. Please understand my answer. So I mean, you need to understand what people think, okay, and then improve on what you were trying to achieve. Compare what people do and compare with what you do, so that you can improve yourself. Okay. You can spend some time reading. You have questions with you, right? Any question? And one thing I note that whenever I ask the student here to ask question, they don't have question. One possible reason I can give is the student here maybe don't have their own thinking. 你没有自己的想法，你只是接受老师告诉你做什么就做什么，做什么就做什么。老师说这个重要你就重要，这个不重要就不重要。你没有你自己的想法。Okay, so one way to ask question is you have to have your own thinking. Maybe your thinking is wrong, never mind. Okay, people will help you to guide you back. But you must have your own thinking. Okay, 不然你就是一个员工嘛，你永远就是一个员工，因为老板叫你做什么你就做什么，很好的员工。Okay, so you have to develop your own thinking. Okay, 你都来到大学了，你一定要学一些你不会的东西 ，develop 你的 skill. Okay, so you have to have your own independent thinking. Then you will start ask question. Because you might go wrong route. When you go wrong route, you have different answer. 哎，为什么这个不可以这样？为什么那个不可以这样？对。Okay, you will start asking question. Yeah, you have to have your own thinking, please. Wrong, never mind. Make mistake, correct it. That's all. Make mistake, correct it. That's all. 就简单，这么简单。OK， 不用怕做错了，做错改过。OK 吗 ？OK, yeah.
So, so according to this solution,
Yeah.
if you just like submission 2,
Uh-huh.
just write one sentence.
Yeah.
You have 2 marks.
Sure. As long as you prove it using the definition we have done, that's all. Yeah, that's all. You don't need to go into detail like why epsilon delta doesn't work. We didn't teach epsilon delta, so no need that part. So just work until what we have in our class. Yeah. So that's why the lecture notes is very important. So the lecture notes will define what I want you to do. Okay, so lecture note very important. It defines what you need to do in this class, need to learn in this class. And then textbook will help you to understand better, maybe. Okay. Okay or not? As long as your statement is clear, then it's okay. Any question on the answer for question 1? Oh, and then another note is part 2. You guys tend to use monotone convergence theorem. So every bounded monotone sequence converges. Okay. So meaning you need to have both bounded and monotone. Only you talk about convergence. Okay. So you cannot use the other direction, saying that if it converges, then it must be bounded and monotone. No. Okay. You cannot just use the converge direction. Converse. Yeah. Bounded and monotone. Okay. Yeah. Oh, and so bounded. So let me write down the logic here. So monotone convergence theorem says what? Every bounded and monotone sequence is convergent. So here, what do you have? Here you have P and Q implies R. Okay, P is sequence is bounded, Q is sequence is monotone, R is sequence is convergent. So this is your logic, the statement of the logic of your statement. Okay, P and Q implies R. So it doesn't imply that R implies P and Q. Okay, but it implies that not R implies not P or not Q. Okay, so this is equivalent to not R implies not P or not Q. Yeah, control positive. So, but you cannot use the converse. Okay, P and Q and Q implies are not logically equivalent. Okay, so far okay, everyone satisfied with the solution here? Yeah. Okay, good. Okay, next. These are the series tests. These are also hard. So I put some hints for you so that you roughly have some idea how to solve them. So for first question here, why do I give you a hint of root n? Okay, so you should think about root test here because both of them have at least power n. Okay, so you use the root test here. Okay, if you use root test here, the extra one here will get you the hint. Okay, the extra power one here will give you the hint. Okay, so you use root test for the first one. How about second one? Second one, I think most of you got it. Quite good. So you just do ratio test. Yes. Question 3. Okay, so question 3 here. So you see that I'm taking a limit. My hint is taking a limit of sine x over x. Okay, so there's some comparison here. Okay, but it's not immediate that you just use x, you use 1 over n, but n to infinity, where you get limit x to 0 when x equals to 1 over n. Okay, so notice that when I discuss this question, right, I'll straight away look at hint. Because in this time consuming period, you cannot just straight away think from that question, how to solve it. You should start thinking from the hint. The purpose I give you the hint is to reduce the time you're thinking. And so make sure you make full use of the hint. Of course, you can ignore this hint, use your own method also. And then how about the last one? Last one, quite a few of you tell me this is quite obvious. Use integral test. So this test is a quite involved one. Quite involved on this test here. The most involving proof. Okay, let me show you all the answer here. So these are the answers. For part 4, right? I want you to mention why you can use integral test. Okay, I allocate about 2 marks for it. Okay, so if you have mentioned it, you get the 2. If you have calculation wrong. So to use integral test, you need to make sure the 3 things satisfied: positive, decreasing, and what? Positive, decreasing, and what? Continuous. Yeah, just mention them. It's fine. Okay, so you need to make sure everything is satisfied before you use the segment or theorem. Okay. Have a read. Okay or not? I think this question is the most people scoring one. And most people score marks from here, which is quite good. Most people score marks from here. Are you here? Please don't write anything on the test paper. Take a picture of it. Okay. Okay. Move on. Okay, next, this power series question here. So this is quite similar to your assignment question. Yeah, quite similar to your assignment question. So for the first part, you check whether the series converge or not, absolutely or conditionally. So you will use ratio test. Right? You use ratio test. Some of you, you just ignore the SN. So this is the difference between series, normal series, and power series. Okay, when you have a power series, you have to consider the power of x. Okay, together as a whole term. And then 2, you differentiate the power series. That means you have to use term by term differentiation. And then part 3 is a tricky part. So what you have to substitute, okay, for your x. So here is the answer. So part one is quite involved here. So you use ratio test, and then after you use ratio test, you need to check the end point where the ratio is equals to 1, because 1 is not, the test is not conclusive or is inconclusive. Okay, so you need to check the end point. Okay, so this is part one. And then part two, you differentiate term by term, then you get what you want. And then part three, you have to do integration. Okay. So when you integrate, you have a constant term that you need to settle. After you settle the constant term, then you need to substitute the right value. Okay. Right value to get the power series that you are looking at. Then you will get these log 2/3. Any question you want to ask about this question? No? The rest? Okay or not? Sleeping. Why sleeping? Why sleeping? Oh. OK 吗？看得懂答案吗？变小，变小，不能太大。我会I will upload the answer later and see. Yeah. Any particular part you want to look at? 没有你想看的部分 ？Part one. Okay. Yeah. Okay. Now, so you need to check the two endpoint x equals to 2 and x equals to -2. How I give mark for this question is if you use the ratio test, I'll give you 3 marks. And then check endpoint for s equals 2 got 3 marks, s equals to -2 got 2 marks, and then conclusion got 2 marks. Okay. 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 2 and 3. Still want to see? 2 and 3. 3. Okay. Some of you just ignore the constant. I think I just take off few marks only. 1 mark maybe. So I mean the way I teach the course is like very pure. So I really focus on the method you use instead of your answer. So your answer maybe just take 1 or 2 marks. Okay. So I really care about how you solve the question. Okay. So far so good. Okay. 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 So let's move on. Question 4 is about Fourier series here. Okay, expand fx equals to x squared around 0 to 2 pi. If the period is 2 pi. And then use part 1 to solve question 2. Okay, a lot of you think that this question is an even function. Okay, this means you got listened to the class. Even then you have a bn equals 0. But is this really even? So what's the function of x squared? So function of x squared looks like this. Okay, it's even for all R. But you see, the interval I take here is from 0 to 2 pi. Okay, for example here, 4 pi squared. Okay, so I really ignore this part here. Ignore the left-hand side. And then what I do, I repeat this shape. Then this is not an even function anymore. Okay, so this is not an even function anymore. Yeah, I think only Larry drew this picture. So really you need to look at what function you're looking at. And then, so I purposely don't pick that 0 to 2 pi because in your lecture note there's a remark, right? In assignment also got a remark, right? You can change the minus LL to any interval A. Okay, so any interval AB you can do the integration. Okay. And then what? Then okay, so if you really just don't care whether even or odd, you just do the AN BN integration, then you should get the answer. If you follow this 0 to 2 pi, then you should get the answer. So most of you just computed AN and then let BN to be 0 because you think that is even. But this interval here, it is not even. Okay. Some of you, although have a wrong answer for part 1, but you managed to do part 2 because the odd part will disappear when you compute this. So even though you don't have the odd part, that's fine. I still can compute it. Okay, for part 2. Any question on this? Understanding this question here? If not, I show you the answer here. So this is a part 1. Okay, so this is part 1. And then part 2 here. It's really similar to a lecture example, just that I changed the interval. What we do here is really the same. Okay, just do integration A and B and then use convergence of Fourier series. Okay, the tricky part here is just the minus LL become 0 to 2. Okay. Okay, no? So far, okay. Okay. Yeah. We can come back if you want later. So question 5, sketch and find the area inside the limit zone. R equals to sine theta and outside the cardioid R equals to 1 minus cos theta. It's very good that every one of you start using the R theta plot. Right? You use the R theta plot to plot this. So the picture is like this. Okay. So if you have this picture, I'll give you 7 marks. Okay. So I think if you're sure where to solve this algebraic equation here, it's probably harder for you to do so. Okay, because you cannot just solve theta equal to something. So this question kind of forces you to draw the picture first. Force you to get the picture first. Okay, then from that picture you can somehow guess where's the intersection and then use algebraic equation to check. Okay. Understand? Okay. So you are at the stage of not just solving algebraic equation. Okay, so you need to do the primitive way. Okay, see from the original picture. So it's inside where? Inside the linear zone, okay, inside the linear zone, and then outside of conduit. So you have this moon here. Okay, you need to integrate over this moon. And then you do the integration. A lot of you forget the square again. Okay, I already remind you in the class for last assignment. You need to have r squared. Where's the r squared come from? Circle. Area of circle, you need pi r squared. Okay, so you need to have r squared. Quite a few of you just use r. Okay, yeah. Okay, now be with the answer. Happy with the solution. Okay, let's see some statistic for this class. Okay, I think your class actually performed quite well. Your average is on, is it? Let me see. Your average is on 51.6. It's quite high. Previous semester only 45. Yeah, actually quite high, 51. And then there are 3 high scorer here. So we have let me see. Yeah, so we have 98, 88, and 84. For this paper, if you get 80 above, you are really very good, performing well. So we have Kwang Ye, Chen Jack, and Larry. Yeah. Okay, yeah, very good. Congrats. Yeah. So if you don't do good in this assignment, it's fine. I mean, test is fine. Okay, you just keep working hard. Okay, yeah, it's fine. Okay, don't get too upset. Don't get too upset. 不要太伤心啊。不要太伤心 ，okay? Yeah. So this test is kind of setting a standard. Okay, I mean standard meaning what I how to say, what I expect if you're gonna do pure maths. Okay, so both you need to be good in concept and calculation. Both you need to be good. You cannot just good at concept. You also need to be able to do calculation. Both you need to master. Okay, so I'm kind of setting a standard. Okay, so you just chase over the standard. Okay, if you chase over the moon, you don't get the moon, you still get the star. Right. Okay. Yeah, you just keep chasing, and then you will get something else. Okay, you will improve along the way. You are even better than last class performing in second year course. They have a lower average, about 49. Second year course. Same batch of students. No, higher. Yeah. Last sem, yeah. Last sem, this paper they got only 45 average. Yeah. 51.6. Yeah, quite high. Yeah. Sorry. Maybe will be 1 mark higher. So please check your test paper if you can earn more marks or I give wrong marks, and then take a picture of it and then return it. later. Maybe 4 o'clock. Yeah.
I think
Which question?
the 5A.
5A.
So I get 3 marks for writing. For pointing, not pointing only the integrate the type of
What do you do?
I write this circle is all I use I think that can show.
It's like you have some indication for your intersection. And that's for the trace of it. Low how, okay or not? Low how? Don't get too sad. Huh? You guys still have exam? Oh, okay, tomorrow. OD and okay, so don't get too upset. Work harder, you get what you want. I will decide how to scale it and then I will let you know how we scale this month. Yeah. Most probably we need to scale our average up to 70. Okay. Yeah.
Oh, one question. What's your opinion on my senior say previous midterm got partial differentiation in school?
What do you mean?
I mean like their previous past.
We don't have it. For my class don't have. Oh, I mean, okay. For my class is like this. Okay, so they have a different order of teaching the topics before me. Okay, but until my turn to teach, I was like teaching with Tao Xian. Tao Xian is teaching probability. So he requested me to arrange the topic like this. So that's why our topics order is as what we have in now. So we do series first, and then we do Fourier series, and then we do curve, parametric curve, and then only we do partial derivative. I think previously they do curves first, and then straight away go to partial derivative. And then series is somewhere in the middle or like, I don't know. So maybe your senior is like very old before. Yeah. So I just keep the tradition. Okay. What else do I want to say? I think your class is performing okay. Good. Quite good. You just keep working hard. Okay, what you mean. Any other concern or not? Any other concern? No. If no, how about we take a break and then you return me your marks and then we will start class. So maybe we take a break until 3, 4, 5. Okay, 3, 4, 5. And then you come back for class. So you can return me your paper now. And then if you have any mark dispute, you just tell me and then I can sort it out for you.
What should I append for this sub question if I have to get full mark? I can. Yeah.
对了，哎，汉伟啊，都不是要加分，看一下。未来better this question.
我可以参考你。我看一下你。
错了。
诶，哦，68，哎 ，correct 68。哎，68. I just copy wrong the marks. In the system is 68. It's already 68. Yeah. Yeah. It's already 68. Okay.
哎呀，
先说有，我就不想说。
Okay, is there anything I can write
Mm.
to get 5 marks for this sum? Okay.
You can.
So for example, like my flow is like ratio is larger than 1 according to ratio test with diverge, right? And then
Okay. And then
okay, I think one thing I should do is specify it's non-zero constant, and then
oh no. Your problem is you don't write out what you say, right? So your argument is like if the limit is greater than 1, then greater or equal or greater than 1? Oh, it's not 0. It's non-zero, right? If the series converge, then the limit is 0. Limit of AN is
or you
what argument you're using? Why does it
the ratio test for series.
ratio test for series?
I think I need to add limit from here. Right limit.
Let me think what you say. Limit of AN. Yeah.
So it's ratio between next term and previous term, and then I take absolute.
Okay, let me see. You should write out what you want to say.
Yeah.
Because I'm not sure
Yeah,
what
bro, you should write.
So let's check. No, let's check your argument is correct.
Oh, I didn't write the what test I'm gonna use.
Yeah.
That lah.
Yeah. Let me see.
第一我没有写我用什么 test， 第二我们 ratio test 我没有写 limit， 第三 C 没有讲 specify 是 non-zero I guess。
So if
然后第四 C 抽出来的时候，因为它是 absolute 嘛，so it's like either a larger than 1。
okay, so if diverge,
negative 1，
if diverge,
something like that。
then greater than. Okay.
哦，
Then
没有写。
then you want to multiply a constant C. But constant C is applied on every C, right?
Yeah.
Every AN.
Oh.
So C and C cancel.
Oh.
Still greater than equals to 1.
Oh yeah.
Yeah. So if it is greater than or equal to 1, then if it is equal to 1, you cannot conclude anything. Only greater than 1 you can conclude.
Okay.
Yes.
Oh, so I need to write strictly greater.
But you cannot.
Cannot.
Cannot, right?
Yeah, cannot.
Because you just say if it diverge, then it is less than
Oh, but it's not the other way. Is it?
No.
It's here to here. It's here to here, but not here to here, is it?
Yeah, because here is converge absolutely, so quite limited.
Okay.
If it converge conditionally. Yeah.
Okay. Think about it. Take a picture.
Yeah. Okay. Yeah.
不知道在是不是这周要交？
下周，但是这周应该要给我 draw。还没有想好题目，要赶紧想，已经很久了。对啊。好。
我做不可以。
看一下。So if Vn and An is diverge, then OK， actually 可以，这是一个我的一个题目。还有吗？
然后还有一个，因为如果我好像是解释的那种方式，然后你去讲回答题目吧，我们
可能呢，这个的 statement 跟那个 statement 不一样。
就是你要写出来，好像是如果是
像我那种写吗？看一下。因为 property of 这个是about convergent 吗？这个是 about divergent 吗？这么 convergent 跟 divergent 有关系，对不对？ 所以你要 mention 那个 Saturday。
那个就是还有我也是
OK 吗？这个 OK 吗？
这个 OK 啊，
这个 OK 啊。
拍
让我加3分。
这电类
拍的啊 ，maybe 会简单一点吧。
考试对我来讲是好像是会很容易发挥失常。
名次，我没有名次哎，我没有名次。OK 吗
OK，
对，这个回程去给他。我挺开心的，所以你们吵一架吧，我人踢我好，反正踢我没这少一些，对，口红这样子。里边这个里边是吧？
There's one thing I want to share. I know that you guys look at the mark quite seriously, okay? Because some of you got scholarship, right? So you need to maintain some above some ranking percentage. But I want to tell you that this is actually not true, not entirely true for your life. That's why I don't like this system. Okay, so if you're gonna give people scholarship, right, just give them because you are give based on their merit. Because you do good, I acknowledge you and give you. But it's not that I want you go and chase like that. Right? This one doesn't make sense. Okay, makes sense for them because they want to make business. But I want to tell you that you have to achieve your best every time. Okay, achieve your best. Okay, so the best is like high distinction. So you achieve high distinction. Okay. Yeah. This is the best you can do. Yeah. So if you achieve your best, I'll make sure that you will achieve your best in your ranking. Okay. Just make sure they achieve your best. Okay. Some of them, they achieve what they want and then they 摆烂. Right. Okay. So this is not good. Maybe you are good, but your attitude is not right. Just not right. Okay. I say once to them, 你要摆烂，你要有实力摆烂。你又没有实力又想摆烂 ，What are you doing？ 可以了吗 ？OK。OK 了，可以吗？哦。Okay. I think we need to remind you. I need to remind you about the project again. Okay, because we have a submission on week 10, right? So let's remind what's the project doing. I think most of you tell me the topic already. I'll try and write. I'll try and list it up this week. Okay, and then if you don't found your topics there, let me know again, or I will check with you again who asked me these things. Okay, I mean discuss with me about the topics already, and then I'll list out in the Moodle so that everyone can avoid each other for the topics. Because we only have 20 people, so we can avoid. Okay, there are a lot of topics you can do. So the LaTeX project here is you just need to write at least 1.5 pages. That's all. Okay. So what you need to write in this 1.5 pages, you need to have your body. Okay. What things you define, what things you want to prove. Okay. And then surround this theory. Okay. You tell me what's the background, what's the introduction to these things. People look at it before. For example, Cauchy proved it, or Riemann proved it, or who else proved it. Okay, from where first we see this theorem. Okay, you tell me the history about this thing. Okay, and then you do example. Okay, you tell me how we use this theory. Okay, in example, squeeze theorem. How to use squeeze theorem? Tell me. Okay, give me two example of sequence. Okay, how to find limit, for example. Okay, like 1 to 2 examples how to use the theory. Right, so this is a shortened form of a paper here. Okay, it's a shortened form of a paper. And then, so this is a project. So you are allowed to do references. Okay, you don't need to like start from scratch. Okay, start from yourself. You go and check whether what you do is correct or not. Okay, and then reference, cite the paper you read. So that's one thing I want to stress here is don't cite website. Don't cite website. Don't cite don't cite website and random web page. Okay. So what you can do is if you see from that website or web page, right, surely they will cite other book, okay, textbook or paper. Go and find those original references, cite those original references. Okay. Like if you okay, one easiest place to do reference, I mean to find reference is Wikipedia. Sure, I go to Wikipedia first. And then Wikipedia will show you a lot of original reference and then go into those. Okay, yeah. Even for us, when we learn a new things, maybe someone say that things that we don't know, we sure will go Wikipedia and then see. We don't believe, we just read first and then we go and check other reference. Because Wikipedia is like most compact, complete, up to date, at least. Yeah. Of course, people can change it, but there are other reference there you can have a look. Okay, no? Yeah. Okay. I don't ask you to copy everything from Wikipedia, but first place you can go and have a look, find stuff. Yeah. Don't use Wikipedia. Go down there. Wikipedia got reference other original reference, and then use those. Okay, read those. Okay. Okay or not? Yeah, don't write too many. 1.5 pages. That's all. Okay. So 1.5 pages. Intro half page. Theory half page. Example half page. Done. Okay, question? How will you question? Ethan? Deadline. Week 11. You're not asking, or you just okay. Week 11. Week 11 Monday, can or not? How about midnight Monday? Monday midnight. So. Hey, how about because our class is Tuesday 3 o'clock, right? Yeah. Then make it Tuesday 2.59. Wow, no.
You are the best teacher.
No, okay. I mean, okay. So after this, you have a last assignment, and then you will start project 2. Okay. Yeah, and then we were done for all the assessment. Okay, project 2 plus presentation, then we are done. Presentation. Oh. Okay. Yeah. Individual. Yeah, individual. And that one is for apply. And then plus one special question I will ask you guys. And then you need to answer. What do you do for project 2? It will be applied maths project. So it's how you apply theory in real life. We will talk about it after project 1. After project 1, we'll talk about it. For presentation, right? You can invite your friend, your lecturer, your favorite lecturer, everyone to come and see it. Okay? So we'll have a Q&A section. Q&A section for presentation. So if you ask question to your friend who present, then you will get marks. Okay, if you ask good question, you will get marks. Okay. Yeah. Okay. So the presentation, I will see your 临场反应, so your reaction on the spot. Okay, so it's like you go and find job, right? You need to interview. Okay, so interviewer, when they ask you for interview, most probably they have seen your CV already, so they are actually okay with your qualification. So they just want to see your reaction on the spot. Okay, so this is the test. Okay, for presentation. See what's your reaction. Okay. So for example, what kind of reaction you need to do? So for example, someone asks a question that you don't understand. Okay, so how are you going to answer this question? You have to face this kind of situation. Okay. Yeah, or they ask a very hard question. So how you react? The matter is not giving the right question, right answer. The matter is how you react to it. Yeah. Okay. So the matter is not whether you know the answer or not. The matter is how you present your idea, your thinking. Okay, whether it's correct or not is another story, but how you give your idea is what I want to test in the presentation. Okay or not? Yeah, you need to learn that. Yeah. Only 5% in future is your salary. Correct or not? In future is your salary. Okay, if you have both a different story, you give interview. Okay? Yeah. Okay, for this project. So if you haven't discussed with me your project title, you should do it soon. And then starting from this weekend, you can start sending your draft in. Okay, I can check for you. Now it's week 9, right? Week 9 and then week 10. So you can give me draft between week 9, week 10, and then submit on Tuesday, week 11, before this class of 259. Yeah. Okay, I will invite you to turn it in. Okay, I will invite you to turn it in. After your draft is okay, you submit to turn it in for check. Check if there's a plagiarism or not. Okay, if the plagiarism is on definition, right, that's fine. Never mind. Definition is universal. Okay, you cannot change much. So my check on turning in is the paragraph you wrote. Did you copy the whole paragraph down or not from somewhere else? Okay, you need to do paraphrasing. Okay, yeah, I'll give you a turning in account and then you can submit and then you check. So in the end, you need to submit a form which I'll give you cover page and then your project and then your turning in report together, 3 things. I will put the detail again. Okay. Yeah. For now, you just give the draft to me starting this weekend, then I will give you feedback. So one thing, because you are the second batch, right? So you have the privilege, you are lucky. So you have something to refer to. Okay, so you can check how they set the document out. Okay, so for example, let us pick someone. We pick this guy. Okay, so you don't have this page, it's fine also. It's fine, never mind. You need to have your title and your name, okay, on it. And then you pick a name for your project. Don't call it calculus project 1. Seriously, I got this. So you need to name your project. Okay, name your title. Don't need this content page also, never mind. We just cut cost. Okay, sure, we'll start from section. Okay, introduction. See, introduce your theorem and then what's the history. Okay, what people did to this theorem before. Okay, and then cite where you read it. Okay, where you get the facts. And then you set the theory up, give the definition. Okay, and then there's a theorem you want to prove, and then prove it. Okay, prove it. Okay, and then prove it. You guys, do you know how to do this equation setting here? You can use begin align, begin equation. Okay. I have the full folder for latex. Hold on, you can use the template there. I
prefer display style.
Display style. Display style can center. Did the center, right? Yeah. Display style is just make the symbol bigger. Right. Yeah. So sometimes because if you don't begin align, all your equation is like on the left. It's very not nice. Okay, a bit ugly. Okay. And then you see there's punctuation you need to take care. Okay, actually here, do we have punctuation here? So you should see now this equation as sentence, as a sentence. So for example, this shows that this limit is greater than this, then full stop. Okay, after equation, you need to put punctuation, full stop, comma, semicolon, or something like that. You should see this equation as a sentence. Okay, so for example, we know that for p greater than or equal to 1, this thing happened. What does this thing mean? This means that the fraction here is greater or equal to this fraction, which is equal to this, full stop. Okay, so now no longer when you see equation you have to see as a sentence, English sentence. OK， 不是一些方程罢了，那个方程是一个句子来的，是一个活生生的句子。OK， it's a sentence, it's not equation. Equation is a sentence. OK 了，适应明白了？要放标点符号是句子。OK， and then no need this conclusion, this part no need, no conclusion. And then reference you need. Okay, 3 important part. Introduction, body, example, and then reference. Okay, make sense? Any question or not on project 1?
So
yeah.
project 1, no need presentation.
No need presentation. Project 1, no presentation. Only project 2 got presentation. Project 2, only 1 page is enough, and then presentation. Yeah, 1 page. Project 2, 1 page, and then presentation. Yeah, what you do on montage. It's a very short project actually. It's just you take random theory and then use real life application. For example, Fourier series. Okay, so this is for project 2. A bit of trailer. So project 2 is like, for example, you take Fourier series. What Fourier series does? Fourier series break down sound wave into cos and sine function. Okay, so what is the useful of this? How many of you have AirPod? How many of you have AirPod? Not just Bluetooth AirPod, need to be active noise cancellation. Okay, so how they do active noise cancellation? They take in the input of sound wave and then they count what's the contribution of the sound wave. And then how to do noise cancellation? Yeah, they produce a negative sound. So they cancel out. Actually, you are hearing something, but that thing get cancelled with the thing outside. So you don't hear anything. They produce a vacuum for you. Okay or not? So how to do this? You need to use Fourier series to check. Okay, to check and then produce the negative of that Fourier series. Then produce that sound for you. Okay or not? Yeah. Okay, so real life application. Yeah. I have to set because last semester, because there are many people, so they have a shorter time. Maybe this time we have a bit longer time. I need to set first. I need to set first. So last year they only have 1 minute to present. So 1 minute, what's the idea? The idea is like, okay, sorry, you should produce a beamer also. Beamer talk. Okay, it's a beamer presentation because your thesis, your FYP has to use beamer. So their beamer is like only 6 maximum. You can use 6 only. Because 10 minutes, 1 beamer. 10 seconds, 1 beamer. So after you talk for 10 seconds, you switch next, and then next. Only 1 minute for presentation. So your presentation is also short. Okay, so you don't need to write long story or what. You know, there's a competition. A lot of university hold it. It's like 3-minute thesis. It's like PhD thesis. You need to say it in 3 minutes. So yeah. So what's the important thing you want to people to know? What's the thing that people can straight away get? This is the thing you need to think about. People have much time. Okay. They only have 3 minutes to listen to you. If you don't get their attention, then they don't care about you already. You know. Okay. Yeah. Okay. So this is what we want to get in this presentation. But we will talk a little bit more this. So that's mean I think I won't make it more than 3 minutes because your stuff is only 1 page, right? So we will make it less than 3 minutes, but exact time we will decide again. And then there's one special question I want to ask you is you need to answer this. So this will have marks. So you answer this question, and I don't want you to give some flourish answer. I want you to give an honest answer, sincere answer. Okay. I tried to think about this question already. So last semester, I asked them a question is what is mathematics to you? Why do you study mathematics? Okay, why do you study mathematics? So this semester maybe I will ask, what does mathematics do to your life? Okay, I want you to reflect on your life. How does this maths affect you? Okay, 你回顾你的人生。Okay， 数学对你有什么影响？ Okay， 数字对你有什么影响？ Okay， then for example, for me, right? When I talk about maths, right, I really think about symmetry. Okay, why this whiteboard looks like this? Why I cannot just simply cut my whiteboard like that? Why I cannot like just simply cut whatever I want? Why cannot I just cut it like this? Why cannot I cut it like that? Why I have to do this square thing? Why is it symmetric? If I cut in the middle, they are the same. If I cut in the horizontal, they are also the same. This is okay. To me, mathematics is like symmetry, a lot of symmetry in life. Okay, why the door like that? Okay, why the table like this? Okay, why the table cut like this and then put together become a circle? Okay, so I want you to think about, okay, your life. Okay, how many years already you guys live in this world? 20 years. Okay, so 20 years. Okay, sure. Okay, 19. Okay, so how does this maths affect you? How you get first introduced to maths? Okay, think about it.
I'm missing homework.
Homework. First time you see maths is homework. Wow. Okay, maybe you can tell us the story. Okay, maybe you can tell us the story next time. Okay, it's kind of interesting. Interesting. Okay, tell me your story. Yeah. Okay. Yeah. Okay. No. Okay. Yeah. Details. We will put in after project. Okay. Yeah. This is the thing. If you have fun things, right? You can let me know. Maybe we can adjust. Yeah. If you have fun idea, you can let me know. Maybe we need to find another time to do presentation. I want to invite the last semester students to come. Okay. Yeah. Let's see how you guys perform. Show them. Okay. Maybe I also get AIT student to come. Also last semester. Last semester I taught 2 classes for calculus. And then I asked the AIT one come to MAT. And then they ask question. Because it's a real life problem, right? So they have some application on computer science. So they can ask questions about computer science. AI stuff. Yeah, AI stuff. Okay. Yeah, it's kind of fun seminar. So yeah. So you should see this seminar just as a discussion. It's just discussion. You are just sharing. Okay, it's not like you like doing some very great things. It's like just discussion, normal discussion. But you talk the most, and then people ask you. It's like a discussion. Okay, you should see as a discussion only. Okay, not too formal, but yeah. Okay, so detail we will roll out soon. Okay. And are you guys ready for new stuff, or you want to do some revision? Revision. I mean the topics. OD. What? OD. OD is hard. Everything is hard. Yeah. After you graduate, it's even harder. Okay. Yeah. Okay, let's do some revision first. And then we'll go into new stuff. Okay, let's start revise from continuity, right? Okay. Let's try this question here. Question 1. So where is the following function continuous? Okay, so this function is defined piecewise. Hey, let me remove this. So here got 3xy over x squared plus y squared. Xy not equals to the origin. then 0 when x1 equals to the origin. Okay, so this is a piecewise function. Where is this function continuous? What do you think? Where is this function continuous? So this function defined for all x1. Okay. So two numbers you can input. So this means this is a function from R2 to R. Okay, because you combine all the numbers together, you get R. Okay. So where does this continuous? OR squared except 0. Okay. Why is it OR squared except 0? Because if you evaluate at x not equals to 0 or y not equal to 0, then the limit exists. Okay, top and bottom doesn't converge to 0. Okay, but the place that go wrong is when x and y equal to 0. Because if you just plug in the value, you'll get 0 over 0. Okay, so what to do? So what to do? You need to check what's the limit of this function at 0. Okay. So how to compute the limit of the function at 0? So let me put here, note that f is continuous at r squared throw away the origin, because the limit of the numerator and denominator limit of the numerator and the denominator is not both 0 when taking x and y to 0. Okay, so how about if we consider the limit taking, wait, what am I writing? So it's not above 0 when taking x to 0 or y to 0. Okay, or exclusively, cannot both together. Okay, if I take both of them to 0, what's the limit? Can you compute the limit? Cannot compute. There's one way to compute, right? It's not obvious from xy coordinate. Okay, so there's one technique you can use. Use the polar coordinate, because there's a lot of square here. Okay, you can try polar coordinate. So what's the polar coordinate again? X equals to r cos theta, and then y equals to r sine theta. Okay, so we replace the limit with a polar limit here. Okay, so we take xy go to 0, meaning we just reduce the radius, okay, from all directions. And then 3x squared become 3r squared cos squared theta, y become r sine theta, and then x squared plus y squared is just r squared. Good. Okay, so you can see that r squared and r squared can cancel. So what do I left with? So I left with 3r cos squared theta sine theta. Okay, right or not? Right now, check. See ya. Okay, so what is this limit here? Regardless what theta here, I just take r to 0. Okay, so this limit here is 0. Okay, but we cannot evaluate this function, right, at 0, 0. Okay, however, we said that we define piecewise that this function takes 0 at 0, 0. Okay, so this means what? The limit of function is equal to the value of the function at 0, 0. Okay, so meaning we fill it in the point. Okay, we fill the point in. Okay, so we fill the point in. So hence limit of fx. Okay, hence since limit of fx of xy to 0, 0 equals to f0, 0, fxy is continuous at 0, 0. Okay. So altogether, fxy is continuous at OR, at whole R2. Okay. Okay. So you need to make sure that the limit of your function is equal to the value of the function at that point, so that it is continuous. Right. Remember the picture I showed you last time, right? So if I have a line, I take away the point, okay, and then I put it somewhere else. Then this function is not continuous. Okay, so you have to achieve the limit with your function. Okay, from left and right. Okay, but this is the R case. In R2 case, you need to do from all. You need to do from all direction. Okay, you need to do from all direction. Okay, all direction. Okay, you need to do from all direction. Yeah, if it's the R2 case. Okay, now. Okay, so this is a continuity. Let's do one exercise on partial derivative. Okay, which one we haven't do yet? Let's do. You guys do PDE, ODE, right? ODE, huh? Let's do some PDE. Okay, so let's do some exercise here. Question 2. Okay, show that the function uxy equals to ex sine y is a solution of the Laplace equation. So what does the Laplace equation mean? So it means that if you take the second partial derivative with respect to x, and then add up with a partial derivative with respect to y squared is equal to 0. And the sum of the two second partial derivative is 0. Okay. Hey, did you ever ask a question why I put del here, not d? Why I put del, not d? Huh? Huh? What's the difference del with d? What's total differentiation? I never defined that. What's total differentiation? I never defined that. Okay, so the difference here is del, meaning that your function have other variable inside there. Okay, so you just differentiate with respect to one direction, x. Okay, with one direction, y. Okay, but if you only have one variable, okay, r to r, fx, you put there or you put d if you want to differentiate. You just put d, okay, because there's no ambiguity there. You just put d. But you have more than one variable, you need to put del, okay? Then you are differentiate with respect to x or you differentiate with respect to y. Okay, you need to tell me. Okay. 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 So how to check this? What do you do to check this? You just partially differentiate your u twice with respect to x, twice with respect to y, and then add them up. See, you get 0 now. Okay. So let's do that. Okay, so how to differentiate u with respect to x? Okay, so you have two variables in your function, right? So when you differentiate with respect to x, you treat the other variable as a constant. Okay, so in this case, what do you get? Sin y ex. Okay, sin y ex, good. So if you differentiate the second time, you should also get sin y ex. Okay, good. So it's just the same ex sin. How about the other one? Sin del u del y. Okay, what do you get? Cos y ex. Ex is a constant. Okay, so let me label here. So you treat this as a constant, and then sorry, so let me move here. Then I write out my function here. Okay, so this time I treat the variable x as a constant. Then we'll get ex times cos 1. Okay, and then I integrate, I differentiate again. Okay. Then I'll get minus ex sin y. Okay, so you can somehow see already. One is ex sin y, one is minus ex sin y. So if you add them together, you will get 0. Equals to ex sin y minus ex sin y, which is just 0. Okay. Okay. So next time, if you see this equation here, don't panic. What you do, you just go and solve it. Try some value. Okay. Okay, so far so good. Yeah, straightforward. Okay, can we go on, proceed? Okay. Okay, so next idea. Okay, so next idea is about tangent plane. Okay, next idea is about tangent plane. So let me motivate this tangent plane, right? Okay, remember last time how we find tangent line for surfaces? Okay, so I have a surface, right? Yeah, I have a surface. So let's say I want to find tangent line on the origin of the middle of my surface here. Okay, okay. Make it a bit like sink. Sink. Okay, good. So let's imagine I want to take a point here, right? So how do I take a point? So from one-dimensional case, right, you are taking a limit of secant, right? You are taking a limit of secant space here. So you take secant like this, approach, and then approach to a horizontal line here, right? So you can take secant here also, and then you keep approaching until you get a tangent line here. But imagine one variable case, you only can take left and right? But here, I can take like a whole circle. I can do it. I can do a whole circle. So many tangent lines. So what are these tangent lines doing? So this tangent line will lie on a tangent plane. Will lie on the plane. Okay, there's a horizontal to this point here, touching only this single point. Okay, so all these limit of this secant line, okay, it will lies on a plane. Okay, so maybe give me one paper. You take this paper, you do it again, and use this paper. So you lie on a flat plane. Okay, here. Okay, all these secant limit of this secant line. Okay, will sit on the plane that only touches one point. Okay, at the point you want to find the limit. Okay, every line. Okay, you do the secant. Yeah. Thank you. So let's give you the picture here. Give you the picture here. So here is the definitions. So suppose f has a continuous partial derivative. So an equation of a tangent plane is the z equal to fsy. So how to find this tangent plane? This tangent plane is exactly built by the fx and fy. Okay, so previously we find partial derivative with respect to x direction, with respect to y direction. Okay, if I take these two together, I can build my tangent plane. Okay, remember in your in your linear algebra, okay, R2 is how many dimensions? Two-dimensional. Okay, so two-dimensional, you need two basis elements. Okay, you need two basis elements. So here is the same. You take two fx and f1 to build your plane. Okay, to build your plane. Okay, and then okay, so this is the formula here. So what's the formula here? So z minus z naught equals to fx evaluated at x naught y naught times x minus x naught plus fy evaluated at x naught y naught times y minus y naught. Okay, so what is this is x naught, z naught, and y naught here. This is the point that you want to find the derivative. Okay, and then you evaluate your partial derivative at that point. Yeah. Okay or not? Okay. Yeah. Okay, let's try evaluate, try and use this formula here. Okay, so find the equation of the tangent plane to the surface z equals to 2x squared plus y squared at the point 113. Okay, so in this case here, the x naught, y naught, z naught is, what's our point here? Our point here is at 113. Okay, so this is our s naught, y naught, and z naught. So what else we need? So we need the partial derivative with respect to x and with respect to y. Okay. So in this case here, we need to compute what is del of fx. Okay. So in this case here, we need to let our z to be our fxy. Okay, and then we differentiate with respect to x. So if we differentiate 2x squared plus y squared with respect to x, what do you get? 4x. Okay, good. How about differentiating with respect to y? We will just get 2y. Okay. So formula says that we need to evaluate our fx at the point we are interested in. Okay, fy at the point we are interested in. Okay. So fx11 is just 4. 4 times 1 is 4. fy11 is 2 times 1, which is 2. Okay. So apply our formula. So what's our formula again? So our formula is z minus z naught equals to fx at x naught y naught times x minus x naught plus fy x naught y naught times y minus y naught. Okay. So in this case here, what's our tangent plane? How about I ask Yeru? Can you tell me what's the tangent plane here? Cannot. So we have all these number already, right? You see, z naught. What is z naught? You know what is z naught? Don't know. So you know what's this notation here? PS naught, y naught, z naught here. So this is actually means that this point is s naught, y naught, and z naught. Okay. So in this case here, do you know what is z naught? Okay. So what is z naught? Please tell us. Done. 3, huh? 3. Okay, 3. How about fx on x naught, y naught? What's this value here? 4. Good. So this is the value of fx at 1, 1. Okay. S minus S naught. What is S naught? Yeah, good. And then Fy at S naught Y naught is 2. Good. So Y minus? Yes, good. Okay, so this is your tangent plane. Should we simplify this? I think it's fine. Okay, you can leave it in this way. Why this way is good? Because you can read out a normal vector from this equation here. You can read out normal vector from this equation. Normal. So how to define a plane? You know how to define a plane? What do you need to know about a plane? What do you need to know? So for example, a line, right? A line, what do you need to know? You need a direction and a point. How about the plane? What's the information you need for a plane? You don't want to tell me every point, right? Every point is like infinite often. Okay, so what is the property that a plane has? Direction. What kind of direction? Two direction. Two direction. Okay, good. Two direction you can define a plane. That's right. Okay, but there's an easier way. Okay, two direction you can define a plane. And maybe you need a point also, because you don't know where is the plane. So you need a point with two directions. Okay, so you need three data here. Two vector and one point, you have a plane. But we can reduce this data actually. Yeah, we can reduce. Can you think of a way? I'm sure you have learned this before. Why?
And if we have a point and then we have a vector, that means that the rest of the space is spanned by the two other vectors, which also makes the plane.
Okay. Okay, that one is a solution from linear algebra. It's like you can break R3 into two R plus R2. Okay, so what's how you characterize a plane? Okay, how do you characterize a plane? Okay, so how do you characterize this plane, for example, right? Okay, so you can find a vector which is a normal vector. What do I call this a normal vector? This means this vector is perpendicular to this plane. Okay, and you can actually move this perpendicular vector around. Okay, you can see that all the vector that you form, okay, from this point to other point in the plane is perpendicular to this normal vector. Okay, so this is actually the definition of a plane. Okay, it's all the point. Okay, all the point that is perpendicular to the point on the vector. Okay, yeah. So all the point on the plane are the point that is perpendicular to the normal vector. Okay, so okay, I think you should ask the question: how is a point perpendicular to a vector? So you need to make up your vector. How to make up a vector? So you take the point where the vector start, okay, and then make a vector to the other point on the plane. Okay, no? Does it make sense? Does it make sense? So let me draw what I say. Okay. By the way, if you don't get my argument right, you should ask. We need to make sure there's a effective communication between us. So you should ask question if you don't understand. So you have a normal vector. Okay, this is what we call a normal vector. And this is what we call a normal vector. And then there's a point where this vector starts. Okay, emanating. So what is a plane? So a plane is all the point. Okay, all the point. Okay, such that the vector formed by the point with the starting point of my vector are all 90° to this normal vector. So these are all 90°, 90°, 90°. So this is the definition of my thing. Okay, so this is actually similar to defining a line. So a line is the direction it goes, but for plane is the orthogonal direction. Okay. So for both cases, you just need a vector and a point. Yeah. Okay, no? Okay, so this is a definition of plane. So definition of plane by using normal vector. Okay. Okay, no? Okay. So so what? So do you know how to read off the normal vector from this equation here? What's the normal vector here? Recall. So a plane, the definition, the equation of a plane is like a times x minus, so the equation of plane is a times x minus x naught plus b x y minus y naught plus c z minus z naught. Okay, where these equals 0. So what are these s naught, y naught, z naught? These are the point where the normal vectors start, or a point on my plane, arbitrary point on my plane. Then this a, b, c, the coefficient of this vector is exactly the normal vector to the plane. Okay, yeah, so the coefficient is the normal vector to the plane. So in our case here is what? 4, 2, and minus 1. Okay, 4, 2, and minus 1 is the normal vector. Okay, so 4, 2, and minus 1 is, so let's say, so let's see, so let's draw these 3D. So 4, 2, and minus 1. Okay, so something going downward. Okay, and then with the point 3, 1, 1, 3. Okay, so 1, 1, 3 is at the top. So maybe somewhere here. 1, 1, 3. 1, 1, 3. Here, negative 1. So somewhere around here. Okay, so this is the plane right there. Okay. Another. Is it? Okay, let me use another color. So maybe somewhere here. Here is the normal vector, perpendicular to this plane here. So what is this plane here? So this is 4 times x minus 1 plus 2 times y minus 1 minus z minus 3. Okay, so here is 4, 2, and minus 1. Okay? Okay. Then actually you can ask a question. What if what do you want to say? Yeah, how about minus 4 minus 2, 1? It also satisfies this equation, right? Equal to 0. If you pick that, what happens? Your normal vector go to the other side. But all these points are still perpendicular to that vector. You're just choosing side for the normal vector. Okay, so if you take negative, right, the other normal vector you will get is in the exact the other direction. Minus 4, minus 2. Okay, it's on the opposite direction. It's 180 to each other. Okay, so the plane is still 90 degrees to this normal vector. It's just that whether the normal, so for the plane, right, there are two normal vectors you can pick. Okay, so one is facing down. Okay, the other one is facing up. Okay, up or down. Up or down. Okay, can get it. So the normal vector for this flat surface here is either up or facing down. Okay. Yeah. Does it make sense? This one will be very important when we go into vector calculus. Whether facing up or down is important later. Okay, but to define a plane is okay. Go up is still the same plane defined by the vector going down. Okay. Okay, now any question? Please ask question. Please ask question. Okay, so what are we really doing here? Okay, so the surface I give you is actually this elliptic parabola. I think you have learned this in your algebra. And when's your algebra analytic geometry? Sem 1, right? Yeah, so you should learn all this picture already. Yeah, because in AIT calculus 2, they have this in their part, but we don't have in your calculus because you covered in the other course. Okay, so actually, if you can recall, this is the elliptic paraboloid. So what do we do? So we have this tangent plane here. Okay, what we computed is a tangent plane. It's a plane. So this plane is touching this surface at 113. Okay, and then what does it do? When I go zoom it larger and larger to the point 113, you can see that this plane here almost resemble my surface. Okay, if I go deep again, actually it somehow reached my, actually it resemble exactly, okay, my surface here. This is the same story in the one-dimensional case. Okay, remember what do we do in the one-dimensional case for tangent line? So let's say we have a curve, okay, we want to compute a tangent line at a certain point. For example, let's say this point here. Let's say this point here. Okay, we drew a tangent line. So what's this tangent line? You need to repeat the process in your mind. I want to draw a secant around this line, and then I look at the limit when I approach the x that I want to find. Okay, I reach this tangent line. So what's this tangent line doing? You see, almost close to this line, the two lines coincide. Okay, when I zoom in and zoom in and zoom in, right, this line, this curve here is actually a straight line. Okay, it's actually a straight line. Okay or not? Okay, so this purple line here, when I zoom in further, is actually a straight line. Okay, so this is the same as surface. Okay, when I zoom in into a surface, this is flat. Again, I want to repeat again. You are standing on Earth. If you see from outside the space, it is spherical. But when you stand here, it is flat. Okay, so this is the tangent plane. Okay, so let's define this. Okay, so that means that we can use the tangent plane to study our surface when we are zooming large enough. Okay, this is what we call a linear approximation. Okay, we make it linear. The surface is not linear, but when we zoom in large enough, it's act like linear. Okay, acting like linear. So this is what we call a linearization. Okay, so Lxy equals to FAB plus Fxab x minus a plus Fyab times y minus b. Okay, so I think if you see this, you fell asleep, right? So many ABC, XY. Okay, so actually there's a meaning here. Okay, so there's a meaning here. So what's the difference between this with what we have just now? Let's see what's the difference. So just now we had Z. So just now we had Z minus Z naught equals to Fx of x naught, y naught times x minus x naught plus f y x naught y naught times y minus y naught. Okay. Do you see any similarity between these two or not? Okay. So actually this AB is what? AB is some fixed point here. Okay. So this is called at the second line actually. So which is not good. So these AB are a fixed point. Okay. These AB are fixed point. Okay. So but there's still difference here, right? If we know that S naught equals to A, okay, Y naught equals to B, okay, what else is the difference? The difference here is here, L, X, Y, and FAB. Okay, so what should these two terms be then? If we compare these two equations here. So we pair out the derivative. Okay, what we haven't paired out is these two terms here. Z naught, and what L, X, Y, and FAB. Okay. So Z naught here, do you know how to get Z naught? If I have a surface Z equals to Fxy, how to find Z naught? I just evaluate X, Y at the X naught and Y naught. Okay, so Z naught equals to F of X naught, Y naught, which is AB in this case. Okay, and then Z is a function in XY. Okay, we call it LXY. We don't call it FXY because it is not the function we're looking at. Okay, here is the linearization. Okay, is the linearization. Okay, can you see the difference or not? Where LXY is a function. LXY is a function. If I consider all the XY, it is a function. If I fix, yeah. So there's a subtlety here. So so what's this doing? This is a little bit like, I think how to say this. So LSY is a function. Okay, LSY is a function. So how is it a function? So this function here is depend on XY we can put here. Okay, so let me think how to say that. Okay, we will see it as a function soon. Exactly behind this. Okay, so this is a linearization. Okay, so this is not Fxy, right? Okay, because we define using the partial derivative. It's just that when we look closer into Fxy at the point AB, okay, AB and then F. This is a linearization at X naught, Y naught, and Fx naught, Y. Okay, we go close into this point, then it almost equals to Fxy. Okay, almost equal to Fxy. Okay, but it is not equal. Okay, almost equal. Okay, let me show you what do I mean by that. Okay, so for example, in a one-dimensional case, okay, so I have this blue curve here. Okay, I want to find tangent line at A. Okay, so what do? I do the limit of the secant. Okay, and then I get this pink line here. Okay, so what do I mean by this pink line here will linear estimate my graph. Okay, so what do? If I evaluate this tangent line, okay, at A, what do I get? I just get FA. So if I do Y at A, I just get FA. Okay, but how about the other place? How do I compute all the other point here? Okay, so this compensation is exactly given by this F prime A of X minus A. Okay, let me show you example. Let me just show you example, exact example. So let's do a X squared example. Okay, let's do X squared example. Let me move it up. Let's move our X squared up so that we can see what we are doing. Okay, y equals to x squared, maybe plus 2. Okay, let me plus a 2 here. So here's the 2. Let's find tangent point. Okay, tangent line at what's this point here? 0, 2. And let's find the tangent line at 0, 2. So what's the tangent? At 0, 2. Okay, what's the tangent line at 0, 2? What do you think? The derivative at here is y dy dx is 2x, okay, where at 0, 2 dy dx equals to 0. Okay, so this line here is y equals to 2 plus 0 times x minus 0, which is 2. So here is y equals to 2. Here is y equals to 2. Okay, so what do I mean by approximate? This tangent line will approximate our curve. Okay, so at the other point, what you have to do? What do you have to do? For example, so let's say what happened at x equals to 1. Okay, when x equals to 1, our point here is 3. Okay, how do you get 3 from this tangent line here? You get 3 from this y equals to 2 here. Plus 1. Okay, so you need to add 1. So this is the difference between the linear approximation. So why do we say it is an approximation? Because there's some difference there. Okay, and then this difference will maybe grow when you move away from the tangent, from the point you get the tangent line. Okay, but when you get closer to the origin, the approximation becomes better and better. You know. Okay, so that's why we put fxy is almost equal to this tangent line here, almost equal. So this almost equal means when you get closer to this AB, okay, AB, FAB, then your function value get closer. And get the difference gets smaller and smaller. Okay, let's look at the surface example. So let's say we have this blue surface here, and then we find tangent line at this AB, FAB here. Okay, and then what does it mean? That this tangent line will linearly approximate this surface is when we zoom in to this AB, FAB, then we will take lesser delta Z, lesser and lesser and lesser. Okay. Okay, so this is about linearization. So what is linearization? Is exactly the tangent plane we are looking at just now. But we see the tangent plane as a function in xy. Okay or no? Okay, function in xy, meaning we go into this tangent plane. Okay, we go into this tangent plane. Or we go to different point on the tangent line. Okay. So away from the point you evaluate the tangent plane, it is the difference might get larger. Okay. Okay or not? Okay. So you see, if you go away, right? If you go away, the difference between the original function and the differential or the tangent plane will get larger. Okay, possibly get larger. Okay, but if for every point, okay, if for every point you can approximate your value of your surface using tangent plane, then we'll call this surface differentiable. Okay. So if you can approximate all your nearby point, okay, using the tangent plane, then your function is differentiable. Okay, so this is what it means by when we take epsilon 1 to 0, epsilon 2 to 0, and the change in x and y to 0, which is equal to the nearby point. Again, we will say that f is differentiable, meaning we can approximate all the nearby value of f using our tangent plane. Okay, in a control way, which is taking epsilon and delta, epsilon to 0. Okay, both epsilon to 0. Then we will say that the function is differentiable. Okay or not? You don't need, I think you don't need to use this calculation here. So what's the thing you need to remember from this line is, at every point on my surface, okay, when I zoom large enough, the value of my f can be obtained using the tangent plane, okay, in a control way. Then my function is differentiable. Okay, so this is the punchline you need to remember. Okay, you don't need to use the epsilon thing to calculate in this course. Okay, so what you need to know is, when does the surface differentiable? Okay, it means that at every point, okay, I can use tangent plane to calculate my value of f, okay, value of surface. Okay, now. Any question you want to ask about this? Any question? Or any question about this notation here that you don't understand? And go a little bit into it if you want. Okay. I don't want to go too deep into this because we don't use it. But if you are interested, we can discuss. If no one interested, then maybe we'll just pass it. So the punchline for this definition is, if I go zoom in enough into my surface, okay, I can approximate the nearby points using my tangent plane in a control way. In a control way. Okay. Yeah, in a control way. Okay, no. So it's like my surface, if I zoom in large enough, it's almost a plane. The control way. Controlled by the epsilon. Okay? Okay. You need to understand the moral. Okay. Okay. So the next theorem is, if I want to prove something is differentiable, then I need to use the epsilon delta definition. Just how we have. Okay, but what we do in this course is, we won't ask you to go to the original definition to prove it. We will use trick. We will use tool. Okay, so the tool we have is here. Let's say we know the partial derivative fx and fy near the point AB, and both of them are continuous, meaning the Claira's theorem apply. I can switch. Okay, I mean, Claira's theorems apply, meaning the mixed derivative is okay, wait. So I'm confused a little bit. So Claira's theorem says what? If the mixed derivative is continuous, then they are equal. Okay, but this is first derivative, so that's fine. So this is first derivative is continuous at AB, then f is differentiable. Okay, so meaning what? How to check f is differentiable? Okay, you need to check few things. You need to find fx and fy, and then see that fx and fy are continuous. And then you will see that the function is differentiable. Okay, we won't prove this. If you are interested, you can prove this. Okay, using epsilon delta. Okay, anyone have any question on how to use this? Okay, if not, let's try it on this example here. Okay, let's try it on this example here. Okay, I give you 3 minutes, you try. After this example, we will take a break. Okay, I give you 3 minutes, try and show this function is differentiable. Okay, by finding fx and fy and see that it's continuous. Okay, try this. Yeah, have a try. Okay. So we want to show that a function is differentiable, right? Okay, meaning what? Every point we can use tangent plane to approximate. Okay, but we don't want to use the epsilon delta definition, so we use the theorem. Okay, what does the theorem tell us? When is a function differentiable? We need to find fx and fy. Okay, we want to find fx and fy, and then see that they are actually continuous at the point we are interested in. So what is fx? E to the xy plus xy times e to the xy again. What is fy? S squared e to the xy. Okay. So what can you see here? So fx are the combination of exponents and polynomial. Okay, so polynomial is continuous at everywhere. And then exponents is continuous also everywhere. Right? Okay, so in particular, they are continuous at 1, 0. So fy is also the same. Okay, so fx, so we see that fx and fy as this near 1, 0, and they are continuous at 1, 0. Okay, why? Since fx and fy are composite and composite of product of continuous function. Okay, so by the theorem just now, not bad. So hence, by the theorem just now, f is differentiable at 1, 0. Okay. Okay, how about linearization? So meaning we want to find, so it is differentiable, right? So if it is differentiable, every point I can find a tangent plane. Okay, what is the tangent plane? So this is what this question asking. So what's the linearization here? Okay, so what's the tangent plane? Remember that for a plane, what do we need? We need a normal vector. Okay, so what's the normal vector here? So the normal vector here is given by the fx and fy, and then minus 1. So the formula here is Lxy equals to FAB plus FXAB x minus a plus FYAB. Okay. And our AB here is Roland, where's our AB in this case? Which point we're interested in? Which point we're interested in? 1, 0. Okay, so our fixed point is at 1, 0. So at 1, 0, where's my surface? So my F10 is, where is it? Is e to the 1, which is e times, sorry. Oh, okay, thank you. So there's a y minus b here. Okay, so what is F10? So 1 times e to the 1 times 0, which is 1. Okay, so the whole point in my surface is a linearization at AB, FAB, which is equals to 1, 0, and 1. Okay, so this is the point we're interested in. Okay, and what is Fx at 1, 0? Okay, we already got our Fx. Evaluated at 1, 0, we will get 1 plus 0, which is just 1. And how about Fy at 1, 0? 1 squared times e to the 0, which is also 1. Okay. Yeah, so we plug every number into our tangent plane. So our tangent plane is Lxy equals to 1 plus 1 times x minus a, which is 1, plus y minus 0, which is 1. Okay, so this is my tangent plane. So if I reduce this, this is just x plus y. Okay, it's the plane x plus y. Okay. Okay. So the picture is like this. So this is our surface here. Okay, so this is our surface here. This green part is our surface. Our tangent plane is at where? 1, 0, 1, 0. Okay, 1, 0 is here, and then at 1. Okay, at the height 1. So let us add another 1. Yeah. So this is the point we're interested. So this middle point here. And then you can see that this tangent plane actually cut through my surface. Actually cut through the surface. Yeah, actually cut through the surface. Okay. Yeah. So what do I mean by cut through the surface? So that's mean if you zoom in and zoom in and zoom in, right? So you can see that on this quadrant here, you need to add value, positive value to your tangent plane to get your function, value of the function. But on the other quadrant, you need to take away the value to reach f, to reach your surface. Can you see it? Okay, no? Can you imagine it? So if you're on a different quadrant, you need to add positive or you need to add negative value to your plane. Okay, so that your tangent plane can approximate your original surface. Okay, no? Okay. I think that there's a similar case in R to R case. For example, you look at the x cube function. You look at the x cube function here. So if you find the tangent line at 0, you also have similar case. Okay, yeah. So you also observe this phenomenon in one variable function, function of one variable. Okay. Please imagine for this topic, you need to imagine a lot. Okay, don't just do derivative, just okay. Find limit. You need to imagine. Okay, need to imagine. 发挥你的想象。Okay. You need to imagine this picture. Okay or not? Okay. Okay, any question up to here? Tangent plane. So linearization is nothing but just a tangent plane. Okay, just tangent plane. Okay. Okay, let's take a break until 5:21. Then we'll come back for chain rule. 是这样吗？
不学工会。
也不用想太少，我有大家喜欢这个问题。X1 啊，
要打过这个氛围。
哎，我忘记问你们，你们在做那个考试的时候，你们是怎么想？啊？
没有时间想。
没有时间想。OK，不然呢？啊？怎么想？
你在打办公网？
没有时间，
呀。
想死。
我想这个，我想知道我说那个的那时候有点。
OK，指引呢？指引呢？哦，他指引一下子就跳去后面了。啊？
跳去前面，那就球。
觉得时间结构了，跟第一题我能换成第一题。觉得时间不够哎。
不够，
真的够。
OK，
对，应该是。
这可以的。
上次考 VT 也是整个是。
probability 这个 probability，啊，
我说水不够，有点虚力的时候，几乎也是考量。
啊，什么？有点多。OK，啊，两个人。OK，
多点多，两个
三个小时。
两个耳闻。两个耳朵
OK，
半日考试不是原本就是选不定哦。
已经固定了，已经固定，final 已经固定。
对，paper 也固定了。
没有。
啊，应该是每个单都是一样的吧？
因为 final 要跟其他人一起考，所以不能够调。
请开final 都考完2号。
没有final 几个小时啊？忘记啊，2个小时好像。
我只要用他考，我不要他管，我要是他一个3月号，哪怕住在里面是电脑，可是我也觉得。
可是你们有感觉这个考试跟你们考数学什么感觉？
作为基本概率。
就是什么感觉？就是有没有感觉要考这份考卷跟你以前考数学考卷不太一样？什么不一样？罗好要思考
英文的意思。
OK，证明题。OK，是 OK，证明题一样。OK，可能你们比较少这个新鲜感，因为你们已经做过 practice question 了。他们上一个 sem 就会感触比较多一点，就因为他们习惯别人告诉他考什么，他就准备那个题目。但是我什么都没有告诉他们，他们什么也不要问，所以我也没有告诉他什么都没有告诉他，所以我们就来哦，我们就一触晴天，就读 content 啊，actual content 啊，教什么就读什么，这样，所以就你准备你的，我准备我的，是不是？对，然后就哇，是哦，没有看过那个题目。
你那时候没有给他们历练考试？
没有历练的，没有历年的，我第一年的。第一个谁？ 没有讲，
不用给他们找借口，就说
没有，我没有否认你们比较好吧，我就说来就就我希望你们能够学到一些东西从考试，而不是来就 regurgitate 的，就是你问反刍要反刍。concept 啊 concept 呀，很重要 counter example、conjure position 很重要。OK 吗？哎，actually 啊，我想问的那些考很高，你们怎样准备啊？比如说问一下那个狂野，你怎么准备那个exam？就做 practice question 罢了。assignment OK。lecture 呢 lecture 有没有？有啊。OK。真正这样准备 prepare， 看我的同学 OK。and then 就这样 let's go OK。就透热有中吗？没有中，我就看这样就这样。细举几个例子，怎么举啊？OK，example，对，这个很重要，这一点很重要。以后还有 pure max 要走，还有4门课里面哪几场？就是 second sem 2个 ，second year first sem 2个跟 second year second sem 2个，一定要拿 compulsory pure max， 然后其他你可以选哦，你要finance 啊 ，computer science 啊，还是 pure max 还是 applied max 都可以选。Yeah，but 你是跑不掉的 pure max。所以你如果要做好，你就是像全健这样，你要有 theory， 你要有 example 在你脑里。OK，Mary 呢？
我也是有自己看了很多，然后我自己在想，然后自己在写笔记这样子啦。
OK，How long 你们 spend 了多长？不错啊，一天还可以拿70多分。那天晚上不是告诉你要70分？几天？4、5天？4、5天还是15天？15天，一个星期这样啊 ？OK 啊，make sense。OK 啊，Yeah，可以的。我去年有一个29分，然后92分的OK 啊，做得到。不要以为你考20多分30多分很差 ，OK。你只要努力，你一定拿得到的。你只要努力就拿得到，肯定可以的。29哎，OK， 我等你啊。可以的。OK， 没问题啊。好，分数只是一个那个 indicator 吧，不是决定你是谁。OK， 剩下半个钟，half an hour，我们快点结束嵌入，然后我们可以下课。OK，so let's talk about 嵌入 here. First variable 嵌入 ，first variable 嵌入是什么 ？What is first variable 嵌入？What is first variable 嵌入啊？So what's first variable 嵌入？So dy dx equals to dy over dt times dt over dx. Okay, what does this mean? What does this mean here? So actually, maybe we change the notation a bit so that Let's resemble what we wanted to do later. Okay, so what does this mean? So this means that our y is in terms of x, but our s is in terms of t. Okay, so we use chain rule. How about two-dimensional case? Okay, if our z is in terms of x and y, okay, we can rewrite x and y in terms of t. Okay, s t y t. Okay, in this case here, if you want to check how my z changes with respect to t, what should we do? So what should we do is here. So dz dt, okay, is equals to del z over del x times dx dt plus del z over del y dy dt. Okay, so we need to add up the contribution from two directions, x and y. But you see here, I put del on z, I put d on x. Why? Why? Why I have a del here, why I have a d here, why I have a d here? Why? Why sometimes I use d, sometimes you del? Uh-huh. Huh? Yeah. Okay, so meaning what? Meaning if I use del on z, meaning z is two variable, more than one variable. Okay, but z, why I say z is two variable, but here I use d, because I can replace all the x, y with respect to t. So my z become one variable in t. And so maybe just f in terms of t. Okay, so that's why I put dz over dt. Okay, but if we want to discuss about z in terms of x, then we need y together. So that's why we put there. How about x here? X is only in terms of t, so we use d. Okay. Similarly, del z over del y because z is in terms of xy, and then y is only in terms of t, so we use dy over dt. Okay, let's look at one example, one concrete example here. Okay, so you see, what I show you is what PureMax will do. I give you a general segment here, and then you need to create example like what Shen said. Okay, so one skill that mathematics can give you is I tell you a general statement, you tell me a specific example. Okay, so let's see how to see this general statement here. Suppose that z equals to x squared y. Okay, so this z is a two variable function here, okay, in x, y. But we can describe our x and y in terms of t. Okay, and then we want to find dz dt. Okay, we want to find dz dt. So what should we do? Okay, so one thing we can do is just use the formula dz over dt is equals to del z over del x dx over dt plus del z over del y dy over dt. Okay, so what should we do? So we need to compute the four function here. Right, four function here we need to compute. So what is del z over del x in our case? Del z over del x. 2, 3, 3x squared times y. I don't know. Yeah. Okay. How about del z over del y? Roland. Del z over del y is what? Differentiate z with respect to y. What do you get? 1. How about your scalar? S cube is a scalar. 拿掉什么？3拿3。So we treat other variable as a scalar. So you should think of it like ky. How you differentiate ky? You get? So you differentiate ky with respect to y, what do you get? K, right? So here, what's the k? S cube. So you should get S cube. Okay, you see S cube as a scalar. Okay or not? Okay. Okay. How about dx over dt? Dx over dt. Lastly, yeah, what is x? Is given in the question. What is x? X is what? 2t. Y is equal to t squared. So dx over dt is what? T again. Differentiate x with respect to t. What do you get? 2, right? Okay, so you get 2. How about dy over dt? 2t. Okay, good. So we just place all these number, this function together. But what did you see here? This number is like we have mix of x, y, and t. So what to do here? What do we do? Substitute x and y using t, function of t. Why? Because we said that z is a function of t. Okay, so we should have everything in t. Okay, okay or not? So we sub everything back to t. So 3 times 2t squared times t squared times 2 plus 2t cubed times 2t. Okay. So all together, I will get 40 e to the power 4. Okay, so this will make sense. Why is this making sense? Because dz over dt meaning change of z in t. Okay, change of z in t. So your variable should be in t. Does that make sense? Okay, you don't want to mix x, y, and t together. So you need to change everything to t. Does that make sense? Okay, so actually there's another way to solve this question, right? Since I said that this z can be written as function in t, how can I do it? Z equals to s cubed y. Okay, how can I write everything in t? I can just substitute what is my x and y. Okay, I can just directly substitute what is x and y. So what is x? 2t. So 2t to the cube times t squared. So what's this? 8 to the t to the 5. And then, can I straight away do dt, dz dt or not here? So what do I get? 40 t to the power 4. So they agree. Okay, so they agree. Okay. Yeah. So see which one is the faster way? 2. Okay. In this case, it's 2 because this calculation is easy. But let's say your z is very complicated, then maybe this will become easier. Okay. Yeah. Depend on the question. Okay. Yeah. So this application we just skip on. Provide solution, and then let's do this one. Okay. Let's do this one. Let you try. You try for about 3 minutes. See what you get. Try this. Yeah, try this. So you need to be aware. You need to be aware what variable you are differentiate with respect to. Then you need to be aware. If you have finished one way, maybe you can try the other way and see which one is faster. And suck everything in, and then you get the same answer. Yeah, so it's not just about getting the right answer. You should see which method you think is most intuitive to you. Okay. Let's discuss a little bit. So how do you memorize this formula here? Yeah? So let me tell you one way to memorize this formula here. So first we start with function z, okay? And my z is in terms of x and y, okay? And then my x and y are in terms of t respectively, okay? And then if I want to differentiate z with respect to t, okay, we need to go down the path to reach t, okay? So for example, if I go from z to x, okay, what I can do is I can differentiate z with respect to, okay, so differentiate z with respect to x, but my z has two variables, x and y. So instead of putting d, I should put del. Okay, and then from x to t, the x I can represent by differentiate x with respect to t. Okay, similarly, for the x going from z to y, I can put del z over del y. And then going from y to t, I can put dy over dt. Okay, so how do I go from z all the way to t? So there are two paths here. Okay, so I need to add up the two paths. When I go down the path, I take the product. Okay, when I go down two paths, I take sum. Okay, so it is the sum of the product of derivative. Okay, is it okay? And use this mnemonic to memorize this formula here. Can or not? Yeah. Any question? No. Okay, let's try this mnemonic here. Okay, so how do we work out the chain rule for this? So this is a 3-variable chain rule, right? I haven't told you how to work out 3-variable chain rule. Actually it is just adding an extra term. Okay, so how to get this using the mnemonic we have just now? So we have w. Okay, we want dw over d theta. Okay, so we have to have a way from w to theta. But there are 3 ways to reach theta here, right? Okay, we can write w in terms of x, y, and z. Okay, but each x, y, and z can be written as theta. Okay, so this is the setting of this question here. So to do dw over d theta, we have to go down the 3 path here and then add them up. Okay, when we go down the path, we need to multiply the h. Okay, so what does this h represent? Okay, so this h are represented by the del of the starting point over del of the ending point. Okay, or if it is one variable, then we just put dx over d theta, and then in the middle we have del w over del y and dy over d theta, and then del w over del z, and then dz over d theta. Okay, from here, from this picture here,
also very clear that when do we put del and when do we put d, right? So when we put del, when the variable has more than one edge coming out. We put d when there's only one edge representing it. Okay, so this is also clear from the number of edge coming out from the vertex. You learn graph, right? Graph theory. So this is like a tree. Is a tree? Yeah. Okay. So how to do dw/dt? Okay. So we have to go down all the path and then add them together. Okay. We go down all the path and then add them together. Okay. When we go down the path, we multiply the derivative. Okay. When we go down the path, we multiply the derivative. Okay. Do you all get this? Try this. Okay. You will get this. Okay. So everyone got this. So we just need to compute what are these products here. And so what are these products? So for the first one, you should get, let me see. Let's check the answer. So first one, you should get 2xy plus z times minus sine theta, and then plus x squared plus 1 cos theta plus x times 2 theta. Do you all get this or no? Get this? Okay, so you can see that here is x, y, z with theta again. So, but our initial derivative is with respect to theta. So we need to sub all the x and y and z in terms of theta. Okay. So all together, oh, I haven't computed this. Anyone computed this? Anyone expanded this up? Kind of crazy. You got it? Did you expand it up? Okay, let's try. What's your answer? Minus 2 cos theta sine square theta minus theta squared sine theta plus cosine cube theta plus cosine theta and then that's all plus 2 theta cosine theta. Anything else? No more. Okay, maybe you can check whether this is true or not. Okay, but okay, what's the next question? So evaluate it at theta equals to power 2. So one way is to you just follow this formula and then evaluate it out. Okay, but you also can do it the other way. So let's say we don't get this final formula because I scared later I have calculation wrong. So what do? So I can get what is the x, y, z when theta at pi over 3. Okay, I can compute what is my point, x, y, z. Okay, so for example, x is cos theta, right? And then y is sine theta. And then z is theta squared. Okay, so I can in turn compute these points. Okay, and then I have theta, I have x, I have y, I have z. Then I can just sub it in here. Okay, I can just sub it in here. If you want to avoid calculation wrong here, or you can do both of them to check whether your answer is correct or not. Okay, so you can try and there are 2 ways. Okay, so let me write down. So there are 2 ways. So 2 ways to get evaluated the w over d theta at theta power 3. So one way is to sub theta into the expression containing only theta, or you can sub theta x, y, z into the Okay, there are two ways you can do. You can check answer for these two. Okay, yeah. When I take A level, right, my mathematics teacher, there's a special way she teaches us. So every question she will teach us how to check our answer. So it's like we will do self-checking for every question. So you can learn to do self-check. Okay, so how to do self-check? If two ways you get the same answer, most probably you are correct. You get what I say here? You get what I say here? Yeah, so there are two expressions for dw of dt. Okay, so one expression you have combination of x, y, z. One expression you have all the data. You can try. That should get the same answer. Okay. Okay. Let's finish up chain rule before we leave. Okay. So the second chain rule is what? So just now we only sub t, okay, for x and y. But let's say we replace x and y with another two variable st. Okay. So x in terms of xt, y in terms of xt. Okay. So what do we have here? Let me give you the tree, the new tree we have, or the trees here. So you have z, okay, in terms of xy, but x and y are in terms of another two variable like that. Okay, so how are you gonna do differentiation? Okay, so this means what? Z can be right entirely in terms of xt again. Okay, so we can have z equals to f xy, and we can have g xt, for example. Okay, everything in xt again. So how are these connect? How does this connect? So this connect by chain rule. Okay, by this chain rule here. So meaning I can do partial derivative of z with respect to x, with respect to y. Also, we can do with respect to s and with respect to t. Okay, but how to find with respect to s and t? So there's a relation back to partial derivative with respect to x and y. Okay, so how to memorize this? Okay, how to memorize this? But to prove this, you need to use the definition. You need to use the definition of derivative to prove this. But how to memorize this? Using the tree again. Just use the tree. Okay. So you start with writing the z, okay, in terms of x and t, and then x and y first, and then x is in terms of s and t, y is in terms of s and t again. Okay. And then let's say I want to differentiate z with respect to s. Okay. How many paths I can go from z to s? How many paths? Two paths. Okay, I can go from z x s or z y s. Okay, there are two paths here. So meaning I need to take the product of the path and then add up the path here. So let's write down what is it. So if I go from z to x, this path, this x is represented by del z over del x, and then x to s is del x over s. Notice that I put del here. Why? Because there are more than one edge coming out from x. Okay? X is defined by two variables. So I only choose one direction. And then z to y is del z over del y, and then y to x is del y over del x. So I go down these two paths, I multiply them, and then I add them up. Okay, so this is the first partial derivative with respect to s. Similarly, if you want to do dz over dt, there are two paths also. Okay, and then you take the product of the path and then you add them up. Okay, so this is the result of the second formula here. Okay, but to prove this, you need to go back to the definition. You need to go back to the definition of the limit, the crazy limit stuff. Okay, you need to use that. You need to replace everything inside here with limit and then show me why the limit equal. Okay, yeah. But for this course, you don't need to know how it came from. You just need to know how to apply it. Okay, yeah. So use this mnemonic to memorize this formula here. right? Produce the tree and then tell the formula from the tree. Okay. So for example, let's give an example here. Okay, z equals to 3x squared minus y squared, where x is equals to 2x plus 7t, y equals to 5xt. Find del z, del t, and del z, del x. So let's draw this picture here, the tree. So z is dependent on x and y, but x and y are dependent on s and t respectively. Okay, so let's say we want to find del z over del t. Okay, meaning how many paths from z to t, okay, in this tree. So there are literally 2 paths here. Okay, so what are these paths? So z to x is del z over del x. X to t is del x over del t. Okay, z to y is del z over del y. Y to t is del y over del t. So 2 paths here, I need to take the sum of the product of each path here. So each path here we get del x over del t times del z over del x, okay, plus del z over del y times del y over del t. Okay, so in this case here, del z over del x, we will get, try again, Roland, what is del z over del x? Del z over del x. What do you get? 6x, good, because you treat minus y squared as a constant, right? Okay, disappear. Del x over del t, Jinsen. Del x over del t. 7, good. Del z over del y, Larry. Del z over del y. Negative 2y, good. Del y over del t, Zhong Yi. Del y over del t. What is y? Del y over del t. 看不到，看不到。眼睛哎，啊 ？Oh shit！
Oh shit！
大家去捞还是什么？y over del t， what is del y over？ 看不到 ，OK。skip Ivan。That's good. Okay, so you just evaluate everything. Okay, you sub all the value in. What sub? X is 2x. Oh, okay. So I combine 42 times 2x plus 70 minus 10x times 5xt. Okay, so we get 84x plus 294t minus 50x squared. Okay, so the other way you can check this is how to check. How to find this answer using the other way. What do? You sub x and y in terms of xt into this function. And then you will get z. For example, you will get z. So this is the first method. Maybe you can use second method. So z equals to 3 times 2x plus 7t squared minus 5xt squared. Okay? So you expand this. And then you do del z over del t. See if you get the same answer or not. Okay? Yeah, try it out. And then use the similar method to find del z over del x. Okay, you can try yourself. Any question on this chain rule stuff? Any question? Straightforward? Okay. Okay. If no question, then next class we will go into implicit function. And then directional derivatives. Okay, so we won't differentiate with respect to x and y. We can differentiate with respect to any direction we want. Any directional derivative. Have you guys seen one video? Have you guys seen one video? Let me show you. Have you guys seen this kind of video before? Have you guys seen this kind of video before? Oh, this one not far enough. Maybe for a further one. How about this one? Need to stay strong. Yeah. I think here can. So this wall is very steep, but then somehow this goat can climb to very high. Why? This is actually very steep. Huh? Of course, their food. No, their food is not too special, but yeah, not really. Just almost the same as normal dog. We will talk about how they climb it up in directional derivative. Okay, is it very steep or is it almost straight? Almost straight, yeah. But they managed to climb very high, super high, like few story high. Kind of fascinating. Hopefully I think we will talk about this next class. And we will see this video again. Okay. Then see you on Thursday.